So we're going to start talking about conservation of momentum. So conservation of momentum is very similar to conservation of energy. The one big difference is that conservation of momentum is very helpful in determining velocities of collisions. So in this scenario, we have a soccer ball that's being kicked into a bucket. So they both have momentum initially. This is a positive momentum to the right. This actually has a momentum of 0 because it's at rest, has 0 velocity. But when the ball is kicked into the bucket, they're both going to move off together with the same speed. So they're going to have a momentum combined. So how we start these problems is we always want to write P initial, momentum initial is always going to be equal to P final of the whole system. So at the beginning we have two separate objects, so each one has its own momentum. Momentum 1 plus momentum 2. This will be our first object, this will be our second object. Okay? When they're combined together, they're really only one object. They're moving at the same speed. So we're going to call that momentum 1, 2, since they have the same momentum together. This specifically is an inelastic collision, where the two objects combine together and move off in the same direction. So our equation for momentum is mv and when they move off together, they have a combined mass, so we want to make sure we add the masses together. And they have the same velocity, so we're multiplying by the velocity total. So just to clarify the difference between these velocities, these are the initial, so we're going to do a subscript O, and this is the final, so a subscript F. And our question is, what is the final velocity of the ball in the bucket? So we're looking for V1 to F. So we need to divide over M1 plus M2 on both sides. And we're left with V1, 2F is going to be equal to the following. We can go ahead and plug in numbers at this point in time. Our M1 is 0.4 kilograms. Our V1 is 8.5. Since the soccer ball is moving at 8.5 meters per second, and it's to the right, so it's a positive number. And our object 2 has a mass of 0.15 kilograms, and it's moving with a speed of 0. So when we multiply by 0, that cancels that factor out, divided by the mass of both. That's supposed to be a 0.15, sorry. When you plug that in your calculator, you should get 6.18 meters per second. And since it's a positive number, that means they're moving off together to the right. Okay, for the second question, it says to compare the initial kinetic energy to the final kinetic energy of the whole system. Was there energy lost? If so, how much? So in these collisions, especially inelastic collisions, energy isn't conserved, meaning the energy initial of the whole system isn't going to be equal to the energy at the end, because there's friction lost when a collision happens, especially when they move off together. So number 2, we need to first find the kinetic energy initial of the whole system. Well, we have two separate objects, they're each going to have their own kinetic energy. And these are the initial, so subscript O. And our energy initial is 1/2 M1 V1 squared plus 1/2 M2 V2 squared. Okay, so let's go ahead and plug in our givens. 1/2, our mass 1 is 0.4, velocity 1 was 8.5. Okay, so since the bucket isn't traveling initially, it has a speed of 0, which cancels that whole term out. And the only energy, kinetic energy that it has is due to the soccer ball, because it's the only one moving. So its energy is 14.45 joules. Let's go ahead and find the kinetic energy at the end. We get KE final is equal to, and at the end, they're combined. So they have a kinetic energy together because they move off together. And so the mass is going to be the mass of both of them. And the velocity is going to be the velocity of both of them that we found earlier in part 1. So it's V1, 2 squared. There it is. So let's plug it in. 1/2 0.4 plus 0.15 times 6.18 squared, you should get 10.5 joules. And if you compare these two, just looking at them, we can see that there's more energy initial than there is at the end. So let's go ahead and find that energy lost. Our energy initial equals our energy final plus E lost. So we had 14.45 joules is equal to 10.5 joules plus E lost. When we subtract 10.5 on both sides, we get an energy lost of 3.95 joules. Okay, let's do one more example problem, and then I'll let you guys try one on your own. So example 2, a 2,000 kilogram car, that's this first car, so let's call that M1. Driving 20 meters per second on an ice rear ends a 1,000 kilogram car. So here's M2 is 1,000. So V1, it was traveling at 20 meters per second, it said. Rear ends a compact car driving 15 meters per second. So that's the velocity of 2, 15. In the same direction. The two cars lock together. What is the shared speed immediately after the collision? Well, we know that it must be somewhere under 20 meters per second, and it must be somewhere over 15 meters per second because momentum is conserved. So they're going to move off with a velocity that's a little bit less than the fastest car, but a little bit more than the smaller car. So let's go ahead and solve for this one. Same setup as last time. P initial equals P final. And our system is P1 plus P2 is going to be equal to the combined momentum. So we get M1 V1 plus M2 V2 is equal to M1 plus M2 multiplied by V1 comma 2. And these are the velocities initially, and this is the velocity at the end. So when we're looking for this unknown right here, when we solve for it, once again, we get the following. And go ahead and plug in your givens. So our mass 1 was 2,000 kilograms. Our velocity 1 was 20, and it's to the right, so it's positive. And actually, they didn't tell you what direction, but you know they're going in the same direction, so it really doesn't matter. You pick the direction. So that's equal to, when you plug that in your calculator, you should get 18.3 meters per second to the right. Okay, for the next problem, I want you to go ahead and try it on your own first. So here it is. Work it out. Go ahead and pause the video. And then when you think you've got it, you can check your work. Okay, so here is the solution to that practice problem. You should have gotten 3 meters per second. So it's the same setup as the last two problems. You get this equation right here. And the mass of car 1 was 1,200 kilograms. Its velocity was 7. Mass of car 2 was 1,600, and it was wasn't moving. It was 0 meters per second, so that canceled that term out. And you get a velocity of 3 meters per second. And specifically, if we were saying these were both positive velocities, it's moving to the right. Okay, let's do one last example problem. So for example number 3, I always like to give you guys a factor change problem. So this time we have a cart with a mass of 2m. So let's call that cart mass 1. And it has a mass of 2m and has a velocity v. So our velocity 1 is equal to v. Before it strikes another cart of mass 3m. So our m2 is going to be 3m, which is at rest. So its velocity is 0. The two carts couple and move off together with a velocity of 1. So once again, this is an inelastic collision problem. And when you notice that two carts are moving off together, then the P final is always going to be a combined mass. And this is our unknown. So it's important to understand what kind of collision is happening, because we're going to go into collisions where they actually bounce off each other and not stick together. But this one, they're sticking together. So we'll have an M1V1 plus M2V2. When we solve for V12, well, first of all, let's rule anything out that has zeros. Since V2 initial is 0, that cancels this whole term out. And when we solve for V12, we get M1 V1 initial divided by M1 plus M2. Let's go ahead and plug in our givens. M1 was equal to 2M, and V1 was equal to V, divided by 2M plus 3M. So you get 2MV over 5M. And our M's cancel, so we're left with 2V over 5. That is answer choice B.